Welcome to this explainer. Today we're diving into a truly fascinating intersection in modern storytelling, which is that exact, incredibly cool point where magic and science collide. We're seeing a massive shift right now in how creators are approaching the supernatural, so let's just jump right in.
So can a photocopier cast a spell? I mean, really think about that for a second. In one of the world-building discussions we sourced for this, a creator posited that if magic is just a quirk of physics, where drawing specific geometric patterns catalyzes a mana field, well, the universe doesn't actually care who or what draws the pattern, right? A human hand? Sure. But theoretically, a standard office photocopier reproducing that exact geometric spell could catalyze the mana just as well, assuming, the magic doesn't blow up the machine first. It totally sets the stage for our deep dive today.
For decades, the absolute gold standard for sci-fi and fantasy world building has been Arthur C. Clarke's famous third law. We all know it. It's the idea that if you drop a smartphone into the Middle Ages, they're absolutely going to call you a wizard. It's a foundational concept that's guided writers for half a century.
But what's really interesting now is how modern creators are entirely flipping the script. Instead of technology being so advanced it looks like magic, writers are utilizing the world builder's inverse. They're treating magic itself as a rigorous scientific discipline. They're asking, hey, if magic exists as a fundamental force of the universe, wouldn't we study it, quantify it, and industrialize it, exactly like we did with electricity?
Which brings us to Section 1, Magic as Math and Tech, a rigorous discipline.
Creators are just completely blurring the lines here. We're talking about settings where fire elementals aren't just mystical spirits. They're literally captured and used to spark industrial revolutions by powering combustion engines. We've got worlds where vampires, or strigo, aren't supernatural monsters cursed by the gods, but the direct result of highly advanced ancient bioengineering. And we have automata, machines imitating life so perfectly through programmed magical logic that they are, for all intents and purposes, alive.
But the absolutely crucial takeaway here is this: magic is not free. If you treat magic as a science, you can't just wave a wand and get infinite power. It requires logic, it requires physical resources, and it requires heavy computational power. In one incredibly detailed system from our sources, mana is actually a non-renewable resource. You can't just cast a spell on a whim. You literally have to do the math.
And I love this. This mathematical cost scales directly with a civilization's technological progress. In an ancient era, spells were simple enough that a wizard could just do the math in their head. But as spells become more complex, look at how this evolves. By the medieval era, a mage needs hours with a pen and paper. During the Industrial Revolution, you need a whole room full of secretaries with slide rules just to cast a single spell. And in the Information Age, spellcasting requires dozens of CPU hours on a supercomputing cluster. The wizard has quite literally evolved into a supercomputer.
Let's look at how this builds into practical combat, like the step-by-step science of a classic fireball. In a scientifically grounded magic system, like the Mira setting from our sources, magic actually acts as a particle that imitates matter. So you don't just shout some mystical incantation. Step 1. You form magic into a combustible fuel. Step 2. You ignite it. Step 3. You apply kinetic energy to propel it forward. It's this highly logical sequence that replicates natural atomic forces.
Of course, sometimes people just fake it. In a post-apocalyptic setting, you might find a raider boss named Brian riding into battle using hidden smoke machines, rumbling floorboards, and heavy metal speakers to pretend he's some mystical deity of destruction. It's a hilarious reminder that sometimes the perception of magic is literally just incredibly loud stagecraft.
But grounding magic in science definitely has its pitfalls, which brings us to Section 2, the Quantum Magic Trap, a lazy handwave.
Enter quantum magic. It's this overused storytelling trope where complex physics jargon is basically used as a lazy excuse for "a wizard did it." Actual scientists and honestly just informed readers often roll their eyes at this fad. Slapping the word quantum in front of a spell doesn't automatically make it hard science. Usually it just means the writer didn't want to figure out the actual rules of their world.
We see this quantum handwave used to justify all sorts of impossible things. Writers use it for teleportation, time travel, and even wave function collapse. The classic Schrodinger's cat analogy. We even saw one source mentioning the use of quantum superposition to explain necromancy, essentially saying a dead person is simultaneously alive in a different reality. I mean, it sounds cool, for sure, but it completely abuses the actual physics.
So, why does this happen? Well, because notoriously, no one actually understands quantum physics. Unless you're a physicist doing the math every single day, quantum mechanics is completely baffling.
And unfortunately, that sheer complexity turns it into the ultimate blank check for lazy world building. If no one understands it, you can just claim it does anything.
So how do we avoid that trap? Let's get into Section 3, Building Better Systems. Grounded magic.
You really have to ask yourself, if you can rearrange atoms to make a fireball, where does the energy come from and where does it go? True scientific magic requires consistent limitations. If you're operating under the rules of science, you are strictly bound by the law of conservation of energy. Asking these kinds of Socratic questions forces a magic system to be beautifully constrained and deeply logical.
It really comes down to a choice between lazy magic, infinite energy, breaking logic, and grounded magic. This is where it gets super exciting. One source described a system where magic is actually a swarm of subatomic nanomachines that link together to perfectly mimic real atoms. When a caster uses a spell, they're really just programming these nanomachines to mimic a different particle or change their energy state. It's strict, it has actual costs, and it is incredibly creative.
Or let's look at one final brilliant alternative rule set, the observer effect. In this system, magic works based entirely on the collective belief of the people around you. It's a really neat psychological take on quantum observation. If the caster believes a spell will work, and the culture around them universally believes that runes have power, the magic functions flawlessly.
But here's the absolute kicker. It only takes one. Just one educated non-believer standing in the room to completely break the system. By watching the spell and fundamentally knowing it defies physics, they can collapse the magic entirely. The skepticism of the observer actually overrides the belief of the caster. What a fascinating cap on limitless power, right? It tightly weaves the society's culture and education directly into the fabric of how magic even functions.
So I want to leave you with this provocative final thought. If you don't learn the magic, doesn't it all just seem like physics? When a magic system is built with immense scientific rigor, strict energy costs, and deep mathematical logic, the line between wizardry and science completely vanishes. It makes you totally rethink the boundaries of reality and the fiction we consume, and honestly, maybe even how we view the incredible, almost magical technology in our own lives today. Thank you so much for joining me for this explainer. Keep questioning the rules of the worlds you explore.